Good morning, everyone. You're listening to 91.7 The Edge, WSUW Whitewater. This is your host, Ken, for the upcoming hour here for the Farms Radio Show, brought to you by the Wisconsin Farms Oral History Project. Check it out online at wisconsinfarms.org. So it's been about 2 weeks since I talked to you guys. About 2 weeks ago, we had Juk Bhattacharya on, and we talked about her life, growing up in India, coming over to the United States, and a lot about the climate. So, today we're going to be talking more about the climate. We have Professor of Geography, Professor John Frye. John, thank you for coming on to the show today.
Thanks for having me.
Awesome. Yeah, so today we're going to go with this usual format that we do. What we're going to talk about is your life growing up, how you end up here at Whitewater, and also what you do, which is primarily meteorology and human climate interactions. So, I read up on you a little bit on your blog that you have at the UWW site. And so today, without further ado, I want to get into, first of all, your life growing up and how that shaped to what you do nowadays. So take us back to your earliest years, that the climate, meteorology, your love of storms, and just weather and the climate, how that first started entering your life.
Well, I am a Midwestern kid, grew up in central Indiana, so very used to rapid changes in the weather, as far as having winter storms and severe storms in the summertime. But three events I can remember as a childhood that really shaped my love of weather and got my interest in weather. One of them was a tornado event. My dad was a local spotter for our community that we lived in. And I remember one time we had a tornado warning, and we had been prepped, got, stuff in our bathroom where we usually sheltered and everything, pillows and blankets to cover up with. And when the warning was issued and my dad was watching, and all of a sudden, out of our big dining room window, about a quarter mile away from our house, a tornado touched down. And was visible to us. And my dad started, of course, yelling at all of us to take shelter then. And so we did. We all ran to the bathroom. Luckily, the tornado just was briefly on the ground, just a matter of seconds. It lifted before it came towards our house and just stayed out over an empty cornfield that, was across the street from our house. So, we didn't suffer any damage, but there was that brief touchdown. And, I just kind of remember that event. And, at the time I was fairly young and, somewhat scared of storms. And that just, kind of excited me. Is just I had a little bit of adrenaline rush when that happened. So that was one event that kind of shaped my love for weather. Second one, probably, I think I was like in 5th or 6th grade. We had a severe ice storm, a freezing rain event, and trees were taken down, power lines were down. We were out of school for about a week. We lost power at our house. I remember our family, we pretty much lived in our family room where we had a wood burning stove for heat. So we stayed there, and I just remember being in awe of, the amount of ice that had accumulated on everything, and the number of trees that we lost in our neighborhood, and, just getting out and playing with friends on the ice. Cause of course that made for good sledding, nice slick roads and hills for sledding. So we got out and enjoyed it, of course. And then about that same time period in my life, we had a severe windstorm in the spring. And, this was an event that happened overnight, and we had suffered some damage at our house, lost a couple trees. Some windows had been broken in our house. And it was just fascinating to me, the sheer power of storms. And, this came without a thunderstorm or anything. So it was a kind of a unique high wind event. And as we go throughout the day, we'll maybe come back to this because I actually have done some research on those type of storms that cause this. So kind of almost coming full circle with that, one of those events in my life that shaped my love for weather.
Oh, yeah, we'll certainly be talking a lot later on besides being a professor, you chase storms too. Mm-hmm. And we'll definitely get into the nitty-gritty on that soon. But yeah, it sounds like you had the whole 9 yards of the Midwestern experience of severe weather.
Definitely.
I really wonder too, even like how many Wisconsinites have gone through all of this experiences themselves too. I know that's mine too. I almost actually got hit by lightning when I was like 11 because it was a camping experience. So I can see why, though, you would be fascinated by this at a young age, especially going through all of that. It's truly a sight to behold and something to experience when you go through all that.
Yeah, definitely. I think, and if you talk to a lot of people in the meteorology field, there tends to be some kind of backstory from their childhood, whether it was, they were terrified of storms and they just wanted to learn more about it, and that kind of grew their passion, or, they just remember some big event in their life that they went through. And that's what kind of piqued their interest in the field of meteorology and climatology. I talk to a lot of colleagues, and it tends to be those type of events that kind of set them into this career path and then to this love for weather and climate.
Awesome. So growing up then, you gave us some experiences. When did you first start taking experiences? Like, I know you had a fascination, but when do you start really realizing that, okay, now this is clear and cut what I want to do with this? Did you first go to school for that? I know I saw on your blog too that, correct me if I'm wrong, you went to the University of Georgia and you ended up there, and then you eventually obviously ended up here in Wisconsin. So do you want, like, for your teenage years, maybe your young adult life, do you want to run us through how you ended up from a fascination into this is something I actually want to do?
Well, I mean, it kind of started in high school, I guess. I had a science teacher that had a passion for weather. So, we learned about weather in an earth science class in high school and had a big unit on weather. And so, again, that's, after these events had happened, and I had that interest and kind of love for weather at that point, but, that just kind of extended a little bit in high school. Being able to kind of formally start learning about it in a kind of school setting and from that academic standpoint. And at that time, I was also a very avid photographer. And so I did a lot of photography work in high school, and then going into college. And actually my undergrad I was a photojournalism major as an undergrad, with a minor in geography, kind of studying weather and climate on the side. And so, building those two kind of loves of photography and weather, I mean, is kind of built my life as well. Been important in my life as far as, going out and trying to take pictures of cool weather events as well. And then in college, when I was at Ball State University in Indiana as an undergrad, again, I started on that track of photojournalism, and it was my junior year, the geography department that I was doing a minor in brought in a faculty member that had specialization in weather and climate. And so that's where I really started kind of buckling down and learning more about the field, taking numerous of his classes there, just learning some basic, forecasting techniques, some climate classes from him. He taught a class would take students out in the summertime in the Great Plains and go storm chasing. And again, you brought that up, that I do that to this day. And again, that's where that kind of grew from, taking that class. After I graduated with my undergrad, I worked a couple years as a newspaper photographer with that photojournalism degree. And the professor, I'd contacted him talking about grad schools, and because I, wanted to go back to school, wanted to advance my understanding of weather and climate. So I contacted him and was asking him about programs. And it happened that he had a graduate assistantship in the program that I had done my minor in as an undergrad. So I was able to go back and work under him and obtain my master's degree at Ball State University as well. Again, focusing the degrees in geography, but again, with that focus in weather and climate. And my master's research kind of focused around severe weather in Indiana. So I looked at mainly tornado occurrences in Indiana from a climate standpoint. And the focus of it was looking at land surface changes. And I kept it pretty basic, and that's typically what you do as a master's student. You have pretty basic project that you work on, research projects. So I looked at land cover properties. So looking at agricultural land versus forested land versus urban areas, and looked at tornado patterns from a climate standpoint. So for over a 50-year period, and looked at where exactly tornadoes in Indiana were occurring. Were they occurring in, urban areas? Were they occurring in more in agricultural areas, more forested regions of the state of Indiana? And what I found was it actually was whenever you transition from one land cover to another, that's tend to be where the tornadoes kind of had occurred across the kind of meteorological history of Indiana in that time period that I looked. So that was my master's research. As soon as I got done with that, I went on to the University of Georgia, like you mentioned, and that's where I did my PhD work. And again, focused on, it was a geography program, but again, with a focus on weather and climate. And again, stayed in that same realm of thunderstorms and land surface properties, land cover properties, and how that influences thunderstorm occurrences and thunderstorm ingredients in the atmosphere. And there my focus instead of on land cover, the agricultural versus forested land, I looked at soil moisture regimes, so wet soils versus dry soils, and to see how they influence not only the occurrence and the initiation or the start of thunderstorms, but looking at where the thunderstorms and at what time of year they developed based off of the soil moisture characteristics.
Yeah, certainly a lot of information, and I can understand too with what you told me too about your master's, PhD, and just even studies beforehand too, and the field studies you did during your time, how it kind of molded what you did and what you are still doing now too. You're a professor and storm chaser, and you do a lot of just like in the classroom work and a lot of field work too, both I'm sure by yourself and with students. Mm-hmm. So we'll get more into that soon as well. But I think it's very interesting too about that mix of just an understanding of meteorology, environmental science, and just especially the area that you're very passionate about of studying severe weather as it occurs, along with the photography and journalism that can make sense of why you're a good storm chaser too. So you given us how you got to that point. Could you explain to us too how you ended up in Wisconsin and specifically here at UW Whitewater, and then we'll start going into about what it is you do here.
Yeah, so after I finished my PhD at Georgia, I had a teaching position at a small university in eastern Pennsylvania, and I taught there for a few years. While there, my family, I've got a wife and 3 kids. We were kind of wanting to get back close to home. Mm-hmm. My wife's from central Indiana as well. So
yeah, she's from your high school, right?
Yep. We're actually high school sweethearts. So we kind of grew up in the same area and went to high school together, went to college together at Ball State. So we were just kind of looking to get back home, closer to home. And so I started looking for jobs, and this job happened to show up, and I applied for it, came here and interviewed, and I guess I did well because I was offered the job. And so that's how I kind of ended up here in Whitewater. It's a great community. We really enjoy living here. The university is great. It's a good place to work, and, very supportive faculty members, colleagues that I have in my department. And I could sense that when I came here to interview that it was that it was going to be a good fit, and I was glad that I was offered the job and ended up here.
Mm-hmm. Yeah, it certainly is a wonderful town too, and it is one of the reasons I just chose to come here as a student myself too. It's I'm sure most people complain about the weather of this particular time of the year. So it's about -2, high of -2 today. But I think with your case that, yeah, I'm sure you'll have to truck through it too. But it's certainly a good variance of someone of what you study in Wisconsin here too about this, and it's pretty good access to other areas. for you want to travel to, like the plains in Indiana and all those other areas that have these cool storm surges.
Yep.
So give us a quick little rundown about what some of the classes you are, and just a little 101 on meteorology, like the basics of it, or at least what you teach.
Okay, so my courses that I teach here at the university, I do a introduction to physical geography class every semester. That's kind of one of the big gen ed science lab electives that are out there that students can take. So I teach that class. Then I also do a introduction to weather and climate class, which is an online class. I do a upper level meteorology class, an upper level class in human climate interactions, and then I do a field course as well. And that field course is a study in severe weather, and throughout that class we learn how to forecast severe weather, and then we spend 2 weeks out in the Great Plains after the spring semester ends, and we go storm chasing. And we try to see real storms while they're occurring. That's the kind of the main goal of the course, but you always can't predict what Mother Nature is going to give you. So we also try to visit places that have been impacted by storms before and kind of see how towns are rebuilding from being hit by tornadoes, whether it was 1 year ago or 10 years ago, and see how that rebuilding process. So we kind of little kind of historical, kind of what we call in our field hazards kind of analysis, how a town kind of rebuilds after a natural disaster occurs there. So we kind of analyze that as well. So you asked about boil meteorology down to the basics. The most basic thing, from a meteorological standpoint is, our interaction between the sun and the earth. The energy that we receive from the sun and how that changes throughout the year is the main driving force for all of our weather and climate patterns, because, changes in the amount of energy influence temperature, which go on to influence pressure patterns. Those pressure patterns influence our winds and how air moves around. So, the basic, if you had to boil it down to one fundamental thing, it would be our interaction with the sun and how that energy enters into our atmosphere, but then also how that energy is absorbed by the surface of the earth and absorbed by the atmosphere and re-emitted back out, and how that process works. That's kind of the main driving force behind most of our weather and climate patterns.
Yeah, I'd say that's definitely one of the better definitions of meteorology that I know too. It's a lot of the ones that I try to do my own little research on this too the past couple of days before going into this, and I know, as you did too, the first I ever went with my studies meteorology is just in high school, so I never went beyond that too, and that's much better than what I heard before too. So I would really like to know too, and I'm sure this is something that everyone really wants to know about, is how does the study of meteorology tie into your storm chasing? And what is the science behind storm chasing, and what does it, what it's for? Because you do a field course that works directly with the students here, and you go out to the Great Plains, and you do this actual literal field work, and doing the storm chasing. And one of the other things you do too is you're mentioning to me too last time we met how one objective you're trying to accomplish is learning with your students are the methods that we have for alerting on storms. Are they efficient? Because I think that the way that the weather and climate interact, so just to give a explanation I found very useful to me too when understanding this stuff better, is that weather is what is occurring or what actually happens, while climate is attempting to predict to the best of our abilities trends or what's going to happen with weather in the future or the long term. So I'd like to know more too about how those things interact, whether it's the storm chasing itself, and going into just about what are some of your objectives that you want to get out of this with yourself and with your students.
Okay, so I mean, I hear a lot of different questions.
Yeah,
there, so
we'll break this down. So
Yeah.
to start off,
So-
we can just go into like the basics of storm chasing and what that is and the science behind it.
Yeah, let's start there. So my goal, so storm chasing as a career, not that it can be a career, it's not lucrative for most people. There's different types of storm chasers. And so one type of storm chaser is just the thrill seeker. They just want to go out. So they want to see a tornado. That's plain and simple what they want to do. Those type of people don't necessarily have a background in meteorology. They don't, most of them probably don't have a intricate understanding of how storms work. Now, most of them will learn it on the fly, but there's those thrill seekers. That's not my goal. We're not out there seeking thrills. There, on the other end of the spectrum, there are the hardcore scientists. They're out. They've got grant money. They've got sophisticated equipment that they are trying to collect data for and get data for these storms that are producing tornadoes and storms that aren't producing tornadoes, so we can try to understand the difference between the two. There's a lot of things that we don't understand about thunderstorms and tornadoes. We still have not really got a good handle on why some storms produce tornadoes and some don't. So there's those hardcore scientists that are out there. They've got, instruments that they deploy in the track of thunderstorms, hoping that it gets hit by the thunderstorm and or a tornado. There are the scientists that use Doppler radar on modified kind of semi trucks that they drive around, and they scan the sky using the Doppler radar. Again, these are kind of big grants they've received to buy this equipment and run this equipment. Then there's another group of chasers that are meteorologists, and they find their thrill comes from the forecasting side of things, and that's where I kind of fall. To me, I see it as a challenge. It's a challenge to kind of analyze a series of maps and understand and figure out where a storm's going to occur. Whether that's just a thunderstorm or whether that's a thunderstorm that would be capable of producing a tornado. Going back to, that understanding of energy is kind of the basic part of meteorology. Well, there's a lot of little intricacies that happen in the atmosphere that are going to dictate whether a thunderstorm occurs or not. And so that's where the class that I teach, that's the main focus, is kind of the forecasting aspect. So, I teach my students to, we learn all about what are the ingredients we need for thunderstorms. How do we analyze those on weather maps? How do we find out where those conditions are occurring? And then you have to then decide what is going to be the best location to possibly see a thunderstorm while we're out there. And that's what we do every day when we're out on the trip. I mean, we wake up in the morning, we have a weather briefing every single morning, and we have analyzed maps. Each day a different group of students is responsible for running the weather briefing each morning. And they've already been up, they've been looking at the weather maps, the weather data that is out there, and they're picking a location that they think is right. Now, I always tell them, kind of jokingly, but in all seriousness, I have the last call of where we go. Mm-hmm. So if they're kind of off, and I try to nudge them a little bit in the weather briefing if they're kind of looking at this wrong location or off just a little bit. And, to this point, I mean, I've ran the class 3 times, and it's gone fairly well. I've never had to really say, totally nix an idea and say, no, we're going here. It's more kind of nudging them and getting them to kind of see other things that are going on as well. And then they're like, oh yeah, okay, I see what you're seeing now. And so, and that's the thrill. And, you know, some days you pick those locations, you then drive to those locations. And, you know, that's part of it is kind of going out to see if your forecast verifies. It's kind of a real-time verification of your forecast. And so we go out there and we, you know, pick a target city and drive there and kind of sit, wait, see if thunderstorms develop. And then if something does, we kind of tag along with it, watch it, see it develop. I mean, that's pretty awe-inspiring. And, you know, you can watch videos on YouTube and online and in, you know, all these Discovery Channel specials and National Geographic Channel specials about thunderstorms, and you can watch it on there. But until you get out in the field and you experience it for the first time and see it for the first time, it's a whole new ball game once that happens. Mm-hmm. And that's where you get that adrenaline rush. You get that, in a sense, you do get that thrill. So we still get excited about it in a sense, but it's kind of a different excitement because it's excited that, yeah, we nailed that forecast. We got the forecast right. We were in the right spot, you know, at the right time to watch this storm develop. And that's kind of my goal, is to teach them how to forecast and get them to understand those little intricacies that are very important in the development of a thunderstorm, and kind of understanding where those are on the weather map and how to analyze them. And it's not all, you know, we're definitely never 100% successful. I don't think any storm chaser ever is. I mean, there are days you pick a spot, you go out there and nothing happens. And then you hear about, you know, that morning you may have been, you know, torn between two different locations, and you go to one location, nothing happens. And then you hear later on there were some storms up in the other location that you had pinpoint. That's part of it, is, you know. But then the best part is the next day we wake up and do it again. We get to learn from our mistakes on those days that we kind of chose the wrong area, and we come back and learn from that. We learn from those mistakes as well. So
yeah, that's what I was kind of thinking too when I was looking into this stuff as well. And you just reaffirmed what I was thinking too. It really sounds like it's almost doing one big intricate puzzle of doing storm searching. I mean, myself, the first thing I would think of as storm searching is the movie Twister, because I watched like 20 million times. And probably not the most accurate depiction of reality, but it's all corny fun.
Yeah, I mean, Twister's I enjoy Twister too. I mean, it's scientifically probably not the best movie. Yeah. But what I like about Twister is, you know, those characters are the people you meet out there chasing. I mean, you know, there's the person that is obsessed with maps and road networks, and they have their maps neatly folded all the time. And, you know, of course, when we use paper maps and not Google and on a phone or something, you know, there's the crazy people that are always saying wacky things, like the character Dusty in the movie. So, I mean, I enjoy the movie. Again, scientifically, not the best, but character wise, those are the people that are out there. And that's the other fun part is, you know, just meeting other chasers, but also, you know, I'm taking students out into the Great Plains, and, you know, up to this point, I've had students before that have never left the state of Wisconsin, and I take them out to the plains. And so just getting them to experience different cultures in a sense, you know, the way of life out in, you know, West Texas is a lot different than it is here in southern Wisconsin. So, you know, just getting them to experience that's another kind of side benefit to taking students out there, is getting them to see those differences that are out there.
Yeah. And while we're on the topic too, I am wondering I'm sure that most of us know that there are a lot of storms and a lot of tornadoes out in the Great Plains. So could you just give me a quick little roundup, like a reminder of what constitutes the Great Plains and why this region? Like, why does this occur there?
So the Great Plains would be from pretty much east of the Rockies. So you would include kind of eastern Colorado, eastern part of New Mexico, and then the states of Texas, Oklahoma, Kansas, Nebraska up into the Dakotas, and then extending. Some people would extend it into kind of the western part of Iowa, south, kind of southwestern part of Missouri, Arkansas, that region right there. So, kind of that mid part of the country is what most people would consider the Great Plains. So why there? Why are storms there? Well, the Rocky Mountains help. And what the Rocky Mountains do is they kind of act as a blocking mechanism. And you need kind of two main things to get a thunderstorm to develop. You need warm, moist air, and you need cold, dry air. And it kind of seems, those are two opposites. Why do we need both? Well, we want warm, moist air near the ground. So we want a lot of heat and moisture near the surface of the earth. Above that, we want a lot of cold, dry air. Because when you put cold, dry air above warm, moist air, that makes the atmosphere what we call buoyant. So it makes the air kind of want to float, just like a boat is buoyant in water because it's less dense. So it makes that warm, moist air want to go up. Well, when that warm, moist air rises, it creates clouds, starts creating clouds. And if it does so rapidly, if that rising motion is rapid, then it's going to create a thunderstorm, a very tall cloud in a sense. And so what the Rocky Mountains do is it funnels the warm, moist air coming up out of the Gulf of Mexico, and it funnels cold, dry air from Canada down into that part of the country. And so that is what kind of starts the process of building the thunderstorm itself, is just that kind of setup of the large mountain chain that's kind of funneling two types of air that we need to create that thunderstorm into that same region. Now, to get the violent thunderstorms that they experience out there and the violent tornadoes, another main ingredient that you need is something called wind shear. And wind shear is how the winds change as you go up in the atmosphere. So what are the wind conditions like at the surface versus what are they, 2 kilometers up and 3 kilometers up, 5 kilometers up into the atmosphere. And so you want those winds to change, and that funneling effect causes a lot of wind shear too, because it's bringing in southerly winds at the surface and more northerly and westerly winds up at that 4 or 5 kilometer point in the atmosphere. And so that creates a turning motion in the atmosphere, which causes the storms to spin, and that spinning motion helps then set off tornadoes.
Well, I think that's a very, very concise explanation, and it makes a lot more sense to me too. Because I know my whole life I've had a general idea about what you all just said, but you giving this such explanation now, it makes so much more sense to me too. And yeah, I think that's so fascinating, especially the Great Plains, where maybe some people might kind of complain, especially in areas like Iowa and Nebraska, about driving through there. But when you bring that into the picture, it makes it so much more interesting. One thing I'd like to know more too about is, so we know now where you go, why you go there, and the different parts each teammate plays in this role, and you as a leader for these students or any other people you might travel with. So can you just give us like a little bit of a day in the life of storm chasing? Because I'm sure there's like 90% is probably driving.
Yep, you got that right. All right, so I'll kind of give it from two standpoints: a day in the life of me, and then a day in the life of what I think the students kind of experience. My day usually starts pretty early. I'm usually get up fairly early, because in order for me to be efficient in helping the students when they're doing their weather briefing, I have to understand what's going on too. So I'm usually up pretty early. I'm looking at weather maps, looking at, the forecast models for the day, seeing how things are in place early in the morning, but then also kind of seeing how it's going to change throughout the day. We then, we've stayed the night in a hotel. We kind of bounce around and stay in hotels, so we get up, early. I get up early, we eat some breakfast, we have our weather briefing, we pick our target city, and then, as you said, it's a lot of driving. So we decide, what time we're going to leave, depending on how close we are to that target city that we're targeting for that day. Depends on when we have to leave, how quick we need to get there. Sometimes it's fairly close. Sometimes it's a, 4 or 5 hour drive from the morning time. Along the way, we will stop and get lunch. We eat a lot of fast food. Not the best thing for you for 2 straight weeks, but that's what we got. We then try to get to our target city fairly early on. That gives us time to reanalyze new data. So we've got obviously internet connection with our phones, but we also have a little Wi-Fi device that we take with us so we can connect computers to as well. So we try to get that target city early. We reanalyze things, see if we need to adjust, see if things are kind of developing like we thought they were, or has it changed? Do we need to go a little bit further? Do we need to pick a new city kind of in close proximity? So we kind of update ourselves along the way. And then we just kind of sit and wait. If we get to our target city, sometimes you're getting to the target city and you start to see thunderstorms starting to develop right then, and you go right into chase mode. Sometimes you get there early and you just kind of sit back and relax and kind of wait for things to happen. And once it starts happening, then again, the chase is on. In a sense, we just follow the storms along, and then we chase, we watch the storms until we can't watch them anymore. Either, at times that's been because storms have moved into areas that don't have very good road network. And so we can't chase if we don't have roads. We don't drive through cornfields like they do in Twister.
Probably not good for the vehicles. Not the
sometimes we call it off at nighttime. Nighttime chasing is not particularly safe. There are people that do it, but with the number of students that I take out, I don't feel comfortable, especially with the lack of experience that they have. If it was me and some of my friends that have been chasing for years, if we were out chasing and it was nighttime, we would probably continue. But, there's a whole level of complexity once it becomes nighttime and trying to chase at night. So we usually call it off at nighttime. And then about that time, as we're getting ready to end the chase, and, this again, we're out there in May, so nighttime is 8, 9 o'clock at night. So it's pretty late in the evening after we've had our weather briefing about 8 o'clock in the morning, 9 o'clock in the morning. So we've been at this for about 12 hours now. At that point, when we're done, I kind of, again, get the handy dandy phone out, smartphone, pull up the hotel apps that I have and find a hotel nearby to stay for the next night. And, sometimes that's, an hour away. Sometimes it's 3 hours away. So sometimes we have a little bit of a drive ahead of us. Usually that means we're also not eating dinner until 8 or 9 o'clock, because if we're in the heart of a chase, we're not going to pull off just to eat. We're going to stay with the storms until they're done. And students are kind of made aware of this early on, so they kind of prep themselves to going long stretches without getting dinner. So that's kind of, and then once we get to the hotel, I'm already back on the computer looking for the next day, kind of do a personal briefing myself. So I'm up usually another hour or two, just kind of looking at how the weather's changed throughout the day, start thinking about what's going to go on tomorrow, and thinking about what time we need to have our weather briefing, because if it's going to be a far drive the next day, then we may need to move that weather briefing up a little bit. So from a logistics standpoint, I'm doing a lot of stuff behind the scenes that the students don't typically necessarily see. Now, I've had some students that have gone on the trip that have been very interested, and so there's been times where they're like, can we meet in the lobby? We'll get to the hotel at, 10 o'clock, 11 o'clock at night. Can we meet in the lobby and start looking at tomorrow? So they're already pumped up, excited about the next day. And so, we'll get together in the lobby and have a small briefing then to kind of get an idea of where we may be going the next day. The students' day in the life of the students, again, I've done this as a student, and I would assume my students have experienced similar to what I did when I was a student and took a course similar to this. You know, a lot of the logistic stuff is handled by the professor. You know, obviously, if it's their day to do the weather briefing, then they're up probably a little bit earlier, prepping for that weather briefing, looking at maps, getting together with the group they're working with that day. If they're not, then they're usually sleeping in a little bit to catch up with some sleep. And then they're, you know, kind of passengers in the car. And, you know, again, we try to go through areas that are interesting. You know, if we have time, do a little sightseeing along the way as we're going from location A to location B. You know, we've done things like Carhenge in western Nebraska, where somebody's recreated Stonehenge with old junker cars. So we've cool. Stopped there. One year that was actually at one of our target cities, so we kind of went and hung out there until the storm started developing. And then once they did, we kind of, okay, let's go, and we went and chased. So we kind of hit things like that, so they get to see a little bit of that. They kind of get to relax throughout the day. I mean, usually it's me and one other person are the main drivers while we're driving from one location to another. So everybody else just kind of gets to relax and chill out for the day as we're driving from location A to location B. Once we kind of get into the chase, you know, my main focus is driving, and I then rely on the students to give me updates. So once the storms start, we're monitoring radar, we're monitoring weather conditions, and that's the kind of students' responsibilities. And this is stuff they've learned throughout the semester when we have the class, what they need to be looking for. And so they know things to, hey, Dr. Frye, just saw this on radar, or hey, check out this weather map, and we'll pull over, take a look at stuff, see if we need to adjust our course that we're taking, our route that we're taking. And so that's their responsibility. And then, you know, again, at night, they can look at the weather stuff too, give me ideas. Again, like I said, sometimes they want to get together in the evening once we find a hotel and kind of just chill out in the lobby and talk about that and, you know, what's going to happen the next day and start planning. So, you know, the best trips are the ones where students take ownership in the trip itself. And while I'm there to help guide them, I can kind of stand back and watch them develop their sense and their understanding of thunderstorm forecasting. And that's the cool experience to me. That's, you know, I find a lot of joy in just watching them learn from their successes and from their mistakes that they make. So that's, I think, the best way I can describe a day in the life of a chaser.
Yeah, I think that's a really interesting explanation too. And certainly a lot of stuff you covered, you'll never see in the very drama-filled storm chasing shows you'll see on TV too, that just show the chase section, and then that's about it. And then the people they cut out, oh my gosh, we gotta get out of here now. And then you don't hear about all the nitty-gritty, like all the other stuff of just this process. And and from what it sounds like too, it's a very team building experience too. I'm sure, like when I said too, you get to do some fun activities too when you're just waiting and driving, and you really get to collaborate together. And it sounds like it's a really good way to bond and to educate one another this whole during this whole time.
Yeah, and the more successful trips are the ones where the students bond better. I have found that, and the ones where the students tend to bond with each other, that's when it's more successful trip and kind of a pleasing trip to be on. Not that any storm chase trip is bad, but there's a different sense when those students bond together.
Yeah, when people are just willing to talk and just interact with one another, whether it's about storm chasing or just life in general, I easily can see how that can make the time pass easier during like the intermission periods and just make it more enjoyable.
Yep.
So we got about 15 minutes left. One thing I'd still like to talk about is, so now that we know what we know about like a general, like a pretty good overview of storm chasing, what are some of the objectives you're trying to do now with like, and you can also explain to me too, because I actually don't know how long you've been doing this. I assume since your college days. But give me an explanation of maybe it could be the past year, just whatever kind of way you want to separate those times of what are some of the objectives you're trying to do yourself and with your students. One being the trying to predict if like some of these storm systems are accurate. And so that might be directly storm chasing. It could be some lab work too, but just an overview of like what you want to get out of this.
So, I, on top of being a professor and teaching the classes, I do a lot of research and try to involve students as much as I can in the research. And that's something that I learned from my professors going through both my master's degree and my PhD is, they were always involving students in their research. Now that was obviously grad students, as a grad student, you're kind of required to be doing research. And so, that's natural. But, I had professors that involved undergrads as well in their research projects. And that's something that also drew me to come to this university and apply for this job as the excellent undergrad research program that we have on campus. And the support that is given to students that want to do undergrad research. So anytime, I'm looking for a research project, I'm always trying to think of how to involve students, because I think that's a good way for them to learn meteorology and or climatology. And so, I've done numerous projects since I've been here, from, climate change across North America to, I've had a couple students work on projects on case studies of particular thunderstorm, tornado events. The one that you have referred to, the one that I'm currently working on is myself and a student, Megan Matthews, we're looking at the verification of thunderstorm and tornado warnings across the United States. And so each National Weather Service office is responsible for issuing any thunderstorm or tornado warning within what's called their county warning area. And they are then kind of judged in a sense on how well those forecasts are, or how well they perform in issuing those warnings. And there's two main statistics. There's what they call a false alarm rate, and then the second one is called the probability of detection. So false alarm rate is if they issue a warning and nothing happens, that's considered a false alarm. So it was a warning that was not needed. Probability of detection is how many events, how many tornadoes, how many hail events do they accurately warn for. So if there's a tornado that happened and it wasn't warned, that's a miss in the sense of the National Weather Service. And we were just talking about this one day in class, and I was kind of explaining the process as I understood it to the students. And the question was raised the concern was raised, well, that doesn't necessarily make sense and gives an accurate picture of how well the forecasting office does, just based off of how it's calculated. And so we looked into it a little bit. We contacted the office that kind of does all the statistics, and just to get a confirmation of exactly how it's all those variables or all those metrics are calculated. And we took that information. We thought, well, again, there's some concern here about the accuracy of how they're doing this. And so Megan and I have been working on looking into these problems. And the concerns that we had are kind of threefold. Number one is, if, let's say, an office issues a tornado warning, and let's say a tornado doesn't happen, then that's obviously a false alarm warning. But that same thunderstorm that happened when they issued that tornado warning may have produced hail or what we call straight line wind. Well, those can be just as dangerous and possibly deadly as a tornado. And so, but the National Weather Service office doesn't get credit for that. That's considered, again, a false alarm because a tornado warning was issued and a tornado did not happen. So we're looking into what we are calling under and over forecasting. So, or warning, I should say, not necessarily forecasting. So tornado warnings issued. Yeah, a tornado didn't happen, but hail or wind event did happen inside that warning. To us, they should get some credit for that because something severe still happened inside of that warning. So we're looking at that. We're also looking at a timing issue. There's some online simulators out there where you can kind of play around being a forecaster and issuing warnings. And sometimes there's events that are on radar look like, well, there could be something there, but I don't really want to issue maybe a tornado warning because I'm not sure. But then you get a call or a report that there's a tornado on the ground, and that's going to set you off and make you produce that warning. So catching things like warnings issued after the tornado happened or started to happen and then continued on in the path. Again, right now, the National Weather Service doesn't give them full credit for the forecaster, full credit for that type of event. So we're looking at that. And then the third kind of concern that we're investigating is the spatial part of it is, they issue a warning box and maybe something happens just right outside of that box. So, they didn't quite issue it in the right place, but it was still in close proximity, and kind of seeing how many of those events get caught from that. So that's one of the big projects we're working on right now, is just trying to get an understanding of how these misses in warnings and events are occurring. Are they a space problem? Is it a timing problem? Is it a over or under forecasting problem? And that's that's the kind of big goal of the research. And Megan presented this at the Fall Undergraduate Research Day, and she'll be doing that again in the spring as well.
All right. Yeah, I think that's a very fair assessment too on just the concerns that even someone like an ordinary citizen like myself will have. Unless you're a grade schooler that's hoping for a snow day, I'm sure that most people would agree that they'd rather have an overshot warning that just never ended up happening over one that just completely went through and no one was even warned about. But I think it's really good to do this idea where you and Megan are criticizing both ends of that spectrum too, of saying that credit is due where it's due. That, let's say, if you predicted that we're going to have snow today and exactly -4 degrees for this time of the day. Well, maybe we didn't have snow, but the temperature has been spot on. And I think that is very credible to still say that, or it's very accurate to say that's still credible. But also, too, that it's something that was just completely missed, that's going to be criticized more as well. So,
yeah, and the other concern that we have is that, we've had some, and again, this is from a severe weather standpoint, is we've had some pretty significant tornado events over the last 5 years where we've had a large number of fatalities. And when they've gone back in and interviewed people, they said, well, we didn't believe the warning because they always issue warnings and nothing ever happens. And so that's kind of that's a little bit of where our conversation started, is about why does the general public, why do people ignore warnings? It's not that, it's not like the National Weather Service office is just having fun by issuing a warning. They're issuing it for a reason. And, to hear that people in the public are ignoring those warnings is disheartening a little bit to us in the meteorological community, because, we're trying to do that to help save lives.
Yeah.
And so, that's, again, some motivation behind this, is to maybe getting a better understanding of these metrics that are used, and show that the offices are actually fairly successful in issuing the warnings and getting that out to the public, so they understand that, the warnings are there for a reason and they are somewhat successful.
Yeah, and I think that's true. It's what this all comes down to too, is just to help people be able to protect themselves and their property to the best of their abilities by getting these forewarnings. And so I think that what you're doing is very good work. But unfortunately, we are getting to the end of the line today too. So there's a lot more that I still would like to talk about if we have more time, such as like the human-climate interactions and just how that even ties into with farming, since, well, this is a farms radio show. But maybe that can just be for another time in the future, so who knows. Is there any last comments, any last, like, even promotions for any projects you do or for your department that you'd like to say before we end off today?
The only thing to kind of promote is we do have a student group on campus called the UWW Weatherhawks. And it's open to anybody who has an interest in weather and climate, whether it's just a kind of a little passion for it or just want to learn a little bit more. Our meetings usually consist of talking about current events or talking about past events and kind of analyzing them. And this is all student driven. And bringing in guest speakers every once in a while. Every once in a while, I've given a big talk about some kind of topic as well. The students have asked me to do that. So, the group is on Facebook and Twitter, and we post our meeting times and stuff and current event or upcoming events on there. So you can just go to Facebook, Twitter, and look for UWW Weatherhawks, and you should be able to find us. So you can like our page or follow us on Twitter and get those updates. So that's about it to promote.
All right. Well, fantastic. Hey, thank you so much for coming on to the show today. It's been wonderful having you, and we've learned all sorts of cool and fun things today.
Well, thanks for having me.
Awesome. Well, everyone, you've been listening to 91.7 The Edge, WSUW Whitewater. This has been your host, Ken, for the Farms Radio Show. I hope you all have, if you're a student, I hope you all have a wonderful winter break. Otherwise, just enjoy the rest of your finals here. Don't get too stressed out. And I look forward to next semester, bringing on more people to talk to. We're going to be having Sage coming on for the first couple weeks of next semester.